Our lesson for today is problems in the real world. First, let's recall, what do we mean by a problem? Anyone? What was our definition of a problem? Anyone?
A problem is something that can be solved.
Okay, anything else? Any other definition?
Problems can be solved through many ways.
You are describing the ways of solving a problem. What is a problem exactly?
Anything that has a solution.
Is that the same thing as what he said? Any other?
Problem is an opportunity for improvement.
You like that definition? It's very positive, so it is an opportunity for improvement. So does this involve a future goal? Do you think if you are intent on improving something, does that entail a future goal? Yes? Yes? Okay. So we want to improve a current state and move it to a better state, right? Now, in the real world, how do people or how do beings, any being, created being, solve their problems? For example, okay, the natural world. So before we go to those specific examples, let's set our learning objectives, our goals for this session. So at the end of the session, hopefully we should be able to name some natural optimizers and cite some real-world problems that can be solved using discrete mathematics. You still remember our definition of discrete math? Do you? Okay. So I assume that you can differentiate discrete from continuous math. Okay. So now let me tell you about what you see. I don't know if you're familiar with the song. Let me tell you about the birds and the bees and the flowers and the trees. Okay, so do you recognize this image? What do you see? What do you see?
A bee.
A bee, okay. Where do they usually dwell? Or where do they spend most of their time? Where?
Flower.
Okay, they hop from one flower to another. And then what are they getting from those flowers? What are they getting from those flowers? Nectar, okay? And then, where do they place the nectar that they gather?
Honeycomb.
In the honeycomb. How many of you have seen a real honeycomb? Okay. Now, do you realize that we have a UPLB bee program? Okay, that's a nationally awarded program. And that's headed by our Professor Emeritus, Dr. Cleopa Servancia. And she was generous enough to give our class actual honeybees. And these were just gathered from their fieldwork. So, how many of you would like to take a look at the honeycomb? Oh, so I see. It's there. So we will have, who raised the hand? This is our hand first. We have two sets actually. And then she also labeled the comb. Okay, so you can take that and then from this side, yes, again. So you can actually read what is the classification there at the back. Now, after examining it, can you pass it around so everyone will see what an actual honeycomb is? So let's see, what was the label at the back from Dr. Servancia?
Comb of giant honeybee. Apis dorsata, Revilugula. Note that the cells are big to accommodate the big size of bees. Date collected October 24, 2015. Combs used for deposition of eggs, used for storage of pollen, used for storage of honey.
Okay, so this is the comb of the giant honeybee. Oh, giant na yan, ha? Okay, what's the other? The other comb with a different color.
Comb of European honeybee, Apis mellifera, cultured bees. These combs were collected from hives on October 26, 2015 in the UPLB apiary. It will be interesting to note if there is differences in math of bee combs among species.
So different species. This one is the European honey. Okay, so please pass it around and then tell me what you observe about the shape of the honeycomb. Okay, so start passing it around. Now for those of you who have seen actual honeybees, maybe you can imagine in your mind what the shape is. Okay. So while the honeycombs from Dr. Servancia are being passed around, okay, let me show you the digital version. Okay. Do you recognize the shape? You? Okay. So what's the shape? Okay, hexagonal. Okay. Now, did you ever wonder why the bees form hexagons instead of, let's say, triangles or squares? Why would they take the effort to construct hexagonal shapes for their honeycomb? Okay. So what's a hexagon again from our high school geometry? It's a polygon of how many sides? 6. Okay. 6-sided polygon. Okay. Now, I really wanted to know whether the honeycombs are shaped like a perfect hexagon. So we had to go to, some of my students and I went to Atisan in San Pablo together with our Undersecretary for Agriculture Policy, that's Dr. Serrano, and Undersecretary for Livestock, that's Dr. Jo Rianda. And this is in San Pablo. How many of you are from San Pablo? You haven't seen Atisan yet? Well, if you can't go there, then just go to the apiary in UPLB. So ask where the UPLB program is so you can come up close to the honeybees and the honeycombs. So these are Kuya Ben's beehives. Okay, Kuya Ben passed away soon after we visited the hives. And these are his bees. So when I first held the honeycomb, I thought it was artificial kasi it was so perfect. Okay, so I was so curious, I couldn't believe that the honeybees were the ones who constructed it. So they had to convince me. You know, Alice in Wonderland, you get curiouser and curiouser. So until I was convinced that it was indeed the architecture of the bees. Okay, so these are my industrial engineering students. And they were not afraid of the bees. I pretended not to be scared myself, but they were friendly. So they fed on melifluous plants and flowers. Okay. Now, let me introduce you to, are you familiar with this personality now, by now? That's Dr. Jin Akiyama from Japan. And not too long ago, he gave up public lecture during the Math Society of the Philippines conference in Batangas, and he talked about math that is involved in art and music. And I became his production assistant, as it were. And you know, you remember our lesson on creating music, harmonious sounds based on the Pythagorean triplets. Okay. He also illustrated that using the accordion. We did it using the, what do you call that again? What did we use? Angklung, the Indonesian instrument. Okay. So now we are going to watch a video clip from his live show in Japan, non-scripted reality show. And he talks about the honeycomb structure. Okay, so did you get the inspiration from the bees and how they solve their problems on the storage space and the use of the materials that they need for constructing the beehives? Okay. So remember that when we do optimize, we make the best use of our resources. So when the resource is space for storage, then we want the maximum space. So from the video, and you can prove this mathematically, okay, if you have time later after class. So it allows the maximum space as against, for example, when we, let's say this is the whole space, when we tessellate it or to cover it, instead of using, let's say, triangles or squares. Okay. We would have more space when we adopt the hexagonal structure. And aside from that, okay, we can also prove mathematically that it uses the least amount of wax because they will have to connect at the 6 sides, each of the 6 sides. Okay. So that's interesting for the mathematically inclined students. So let's look at some other honeycomb structures that we see all around us. Okay, can you come up with a pencil if you brought one, especially the unsharpened one, the new one. Okay, examine the shape. Vanessa, do you have a pencil? Okay, maybe we didn't notice it, but it has a hexagonal tip. Any other object that you can find among your things, okay, about the structure that is hexagonal? Now let me show you this one. Okay, maybe you're not familiar, but this is what we call charcoal briquette. Okay, these are made of yard waste. This technology was popularized by the ERDB, the Ecosystems Research Development Bureau. So if you're interested, it's just near forestry, and it solves somehow the problem of cutting trees to make charcoal because you make use of the natural yard waste. And the machine would come up with briquettes like this. Okay? So the technology is so useful for our people in the communities. So look at the shape, and of course this one. I'm not endorsing it because I don't want you to develop kidney problems if you eat too much of this, but did you notice the shape is also hexagonal? So now I want all of you to be more keenly aware of the hexagonal structures around you. So from now on, start looking and then take a picture and then upload it in our Facebook. Just like the way you did it for the rouleau triangle, constant with possibility for manhole cover. Okay. Now aside from that, there is also another problem that is solved by the honeybees, and that is how to find food. It's called food sourcing. So let's check this out. And it involves a dance, some kind of a dance, which they refer to as the waggle dance. Okay. Do you remember your trigonometry? These know their trigonometry. They use the dance to communicate where they can find the food. So solve na yung problem on how to find the food just by one bee doing the waggle dance. And of course, you should not be sleeping while the bee is dancing because you have to be very attentive to the direction. Okay. So what is involved? The math involved the angle from the sun, which indicates the direction, and then the duration of the waggle dance, which indicates distance. So it's like a vector thing, right? Vector with magnitude, the distance, and the direction. So, what did Dr. Jean Akiyama say? They are geniuses, aren't they? And one other thing that I want us to notice is that they sing while they work, they buzz, okay? And they produce such sweet results. So I brought, so for those of you who haven't tasted honey, anyone? This is new. Actually, this is old, but this is newly opened by Vanessa. This was produced at the Atisan farm I showed you a while ago. So, from San Pablo. Now, you know, even if you put this in the ref, it doesn't coagulate. So, it's real honey. There's no sugar, no artificial sugar. So, let's ask the people at the back to have a taste. Anyone? There is You can open it, ask the, and we have some spoon here. And skyflakes, okay? Or if you want, you can, that's good for tea. Tea with honey as well, so it's very healthy. So now, would you like to place some here? And then tell us if it is indeed sweet. Remember the bees that we held, my students and I held, they were the ones who produced that. Of course, it was packaged by Kuya Ben. The factory is right there in Atisan. So how about if we go there for a field trip, right? Okay, for finals. Okay, but we need to get permission from the college because that means final exam, may moratorium na. Okay, so this is the other thing, you know, the NSTP class in Diliman. What they did was they went to Zambales where the itas are, and then our brothers and sisters in Zambales, the itas, are very good at honey production. Now, I'd like you to remember, have you ever wondered why there is a bee program? Why are we so interested in bees? Is our existence dependent on bees? Read Einstein, what Einstein said about bees. Maybe we should let's ask Sir Artie kasi he's ang kanyang SBIBs. Did you realize how important bees are, Artie, aside from the optimization? Why are we interested in bees?
Bees are important, especially in agriculture, kasi they are the primer pollinators ng mga products na napaproduce ng agriculture. And hence, it will yield to better production para sa sector ng agriculture. Kaya important yung bees.
And we are dependent on agriculture for our existence. Unlike we will all be eating GMO food na not natural. Okay, so, but that's how important they are very careful about colony collapse, right? So they want to preserve. And we have very good species in the country. So the itas know that instinctively they know that it kills bacteria and it disinfects wounds. Okay. Now this is my attempt at looking for hexagonal structures. You can find your own. Did you notice? This was taken in Erie by the Undersecretary for Agriculture, Dr. Brent Serrano. And he was waiting there the whole morning. Okay, it's called, can you read that? Barn swallow. And it alighted on the post in one of the experimental farms in Erie. Have you been there? Okay. And then suddenly it catches the prey, no? And it catches the prey up here. And when it opened its mouth, big actually, lo and behold, it's a perfect hexagon. Why is it made like that? Have you ever wondered? Relating it to our lesson? Okay, now, let's see, let's move from the natural world, the honeybee, to something that we do in the real world, the industry. Remember, when they do package products, they have to make sure that the space is maximized. Okay, so we have here another object media. Okay. So have you seen this one? It's good if you are having if you are battling your sore throat or your bad colds, then you can take fresh juice. It's a bit costly, but at least it's healthy. And you know, they want to package these ones, like this product, in boxes. So if we are going to, okay, look at this, how many cans of this fruit juice are already packed here? So we have 1, 2, 3, 4, 5, 6, 7, 8 rows, and then 5 columns. So we have a total of 40 cans. Okay. So the problem is, how will is it possible for you to pack this along with the 40 cans? Anyone who wants to try? Okay, anyone? The one who will successfully pack this along with the 40 cans will get a taste of the honey. Okay. Yes? Sige. Who wants to try? Yes. Maybe in the middle so that the others can see how he does it. Can we borrow the chair, please? Okay, keep trying. Do you remember how Dr. Jean Akiyama did it with the hexagons? Very close. Plus, he didn't drink the juice. It's here. Where's the ribbon? There. Okay, let's give, what's your name again? Rai. Let's give Rai a big hand. So, it's one can more. But can you imagine if the packaging box is larger and we have more to pack and other things that we pack aside from this one? Okay? So that's a problem in the real world, maximizing the packaging space. Okay, now let's move on to another creature that has inspired us to solve real world problems. And what's this again? If you can recognize this big version of the little creature, what's this again? The ant. Okay. Have you seen an ant colony? Yes? Okay. And in literature, they use the ant to encourage us to be more industrious. They have a very good system. They communicate, they work hard, they save for the rainy days, etc. So we have very good lessons gleaned from the ants. But aside from that, from the ant colony, okay, we have an ant colony optimization algorithm. If you are from ComSci or from Applied Math, then you are introduced to this algorithm. But we don't go into the details now. All I wanted you to know is that this solution procedure was based on the behavior of the ants when they are looking for their food. Okay? So have you ever observed ants looking for their food? What do? They do it alone? Okay? Straight line or not? It's not necessarily a straight line, but it should be the more or less. Would they go around and take the longer path, or would they opt to get the shortest path? Okay. For example, one of my advisees had this as her special problem. It's the garbage collection. So how would you guarantee that all of the houses in the subdivision are visited by the garbage truck? Okay? And this is a site-specific problem in Lipa City. So my student used the ant colony optimization algorithm to get the initial tour. Okay? Now, how did the algorithm develop? It was first published by a PhD thesis by Mark Codorigo. And the principle is like this, okay? So if you have, anyone can guess this one? It's a perfume, okay? So if you put the perfume on, can you try it on yourself? So for how long will the scent last? Okay? So the ants emit pheromones. Okay? And for the pheromone not to evaporate, okay, they have to make sure that they take the more or less shortest path, so that the ones following can still smell, as it were, the perfume emitted by the lead ants, okay, or the ants in the pack, okay, in the line. So that's the idea. So and again, biomimicry, we mimic what the natural world does, the natural creatures do. And these have been used, the algorithm based on the behavior of the ants, have been used to solve traveling salesman problem. Of course, that's a classic problem in operations research, but the applications are when we do the network problems or when we work with urban transportation systems. Do you think we need this in our country? With the heavy, or the traffic, the queue that's building up very quickly. Or in road networks. Okay, so imagine a problem where you have to connect households or cities, okay, by means of road networks. And what would be the shortest way of doing it, the shortest path, okay, to minimize the length. So to minimize the length would mean to minimize the cost because you need the material, just like the way the bees minimize the cost or the amount of construction materials that they need for the hive, and they gather that material themselves, okay? And for example, if now you are involved in the tourism industry and you want visitors to at least see the 15 largest cities in Germany. So we have to come up with the possible tours where the sites are visited exactly once. Or if we want to expand that to larger areas like ang grandiose landscape ng US, then we can also apply that algorithm. Or, okay, this one is a famous artwork. That's the most visited piece in the French Museum. And if you look at Mona Lisa closely, somebody very artistic transformed this into a traveling salesman problem using 1,000 dots, okay, that were connected, or vertices, as it were. So it's a continuous line drawing, so piecewise. Okay, so that was generated, the portrait was generated using that. Okay. So let's leave the ants in peace, and then let's move on to the lizards. Just recently, a German scientist came to IBS to talk about game theory among the natural creatures. And one of the simplest that I think you would be familiar with is the game played by the lizards. Okay? So how do they play this game? It's like your, what do you call that? Bato-bato pick. Okay, so it's like your bato-bato pick where the scissors win over the paper because the scissors can cut the paper. The paper can win over the rock because the paper will cover the rock. And the rock will win over the scissors. Why? Pupukpukin yung scissors. So the mating strategies, because they have to compete for a mate. So they are multicolored. So if it is an orange lizard competing with a blue one, automatic yon. There is, kumbaga, code of honor na nila yon na the orange beats the blue beats the yellow, and yellow beats orange. So can you see the structure like the rock, paper, scissors thing? If you're going to put that in the structure of the Jack and Paul game. Okay? Okay, let's recall again our natural optimizers. We have the bees, okay, the ants, what else? The lizards, okay, and the geese. and collaboration. Okay, teamwork, that's 21st century skill. Team means together everyone achieves more. The value of encouragement, not putting ideas down, especially out of the box ideas. The logic of love, sacrifice. Got that. So I hope you learned something from the geese and how to optimize their flying range using the V choreography. So next time you go to the fruit stalls, observe carefully how they present their products or how they arrange their products on the stall. Okay. And later, I would like you to do some research, just Google. How do the Japanese pack their watermelon? See, diba? The watermelon will create space, just like the ones that you saw in the canned products of the fruit juice. Okay, anybody who knows what the Japanese did to pack more watermelon? Anyone? You have to find out. The shape of a watermelon is, they made it into a square. Okay, ano kayang lasa? Pareho lang naman yun. Okay, but square watermelons. Okay. But let's say round fruits, the watermelon is not perfectly round. Some maybe are, but minsan, di ba may ganung watermelon? So how do you get more oranges? So it's like, remember the activity a while ago, so you can get the idea from there. So parang, sa dance, ano ba tawag namin dito? Window choreography. Okay, so that's the most efficient packing. So anywhere in the world, you would see this pattern. Okay, in Europe, in the Philippines, in Asia, and the rest of the world. Okay. Now, this is something we should be proud of as Filipinos because, of course, we have a lot of health problems. And what do you think is the #1 killer? I mean, one of the #1 killers in the country and the other countries? Okay, the big, aside from heart ailments, we have a battle with the big C. Right? Okay, so this is the paper that won the hearts of the judges in the US. And this is a refinement of breast cancer detection techniques. So what Dr. De Guzman, now Dr. Yu, who is teaching operations research at Ateneo de Manila University, did was to use the nonlinear form for the problem solution. Okay, so it's very mathematical. But this landed on the front page of our Daily Inquirer many years ago, 1999. So that goes to show class how Filipinos are very good also at problem solving. Pwede natin ilaban sa international arena. So that's Dr. Maria Lourdes de Guzman. Okay? And I'd like you, because of the digital age, you can easily access this. Just type in forms and you will see a list of all the other problems that can be solved using this great math, especially the all-purpose algorithm, the simplex method, which is for linear programming. Okay, so let me remind you again what we mean by OR. It's operations research, sometimes called management science. So we manage problems by using mathematical models. In this case, it's dubbed as the science of better because it can improve systems. So if you have a problem, you can make things better. It's an opportunity for improvement. So again, I'd like you to visit this site because it tells us the problems that can be solved using math, or in particular, the field of operations research. So the math or the operations research in particular, which is behind the things that we are concerned about. For example, in this climate change era. Okay? So, the environmentalists would be very keen on this. So we want to measure the carbon footprint. Rotary Club is taking a lead on this. So the analysts now can determine the boundaries of the carbon footprint model. Or if you are taking a flight, when you hear your captain speaking, okay, so this is your captain, you're cruising 2,700 miles above sea level. And before it went into that flight, okay, make sure that there was a lot of planning or programming that has been involved in terms of the shift periods, the assignment of the ground and the air crew, the captain, and the rest periods and all that. So it's a staffing pattern. Okay? Or the navigation system. Sir TJ has a very good navigation system in his car. He just tells the gadget, take me to work, and then it will lead you to the workplace. So there is an optimum route. Okay? Of course, the vehicle will not bring him all over, but there is an optimum, minimum route, shortest route. Okay? So for monitoring the journey. So for those of you who are interested to study this further, you can shift to math or apply math, or you can do it as a hobby. Okay? You can self-learn about these things. So industry problems. Are you familiar with this logo? How many of you are buying products of this? Okay, can I have a quick survey if you are taking or buying any of these products? Is it familiar to you?
Yes, yung coffee, iced coffee nila.
Coffee, ano pa? Do you realize the variety of products produced by San Miguel? And do you realize how long this company has existed in this country? So it's one of the top brands actually. I'm not promoting it, but I'm just showing you because it has won the ORSA prize, the Operations Research Society of America prize, next to FedEx. It's a food, beverage, and packaging company, and they are diversifying. They have an operations research team, okay, that determines the decisions, the strategic and the strategic decisions and the operational decisions of the company. So for example, in matters of routing their vehicles, the delivery vehicles. So what they do is they ask questions. So it is important to ask questions. So we have a problem of how do we make sure that all the deliveries are made. So, and then the analyst would turn these questions, okay, they determine the real problem, not just the perceived problem, and then they turn this into a mathematical model. Okay. We study this in our higher applied math courses, and it's a very simple model, right? It's a very simple network model. So you just need a simple linear algebra for this one. Okay. And another problem would be warehousing. So again, they can ask questions. How many warehouses do we need to maintain? Where do we locate these warehouses? Where should we build the warehouses? Or should we just rent the warehouses? What's the size of each warehouse, for example? So note that these are decisions. When you answer these questions, these are decision-making problems. Okay, and then they have to make sure that the demands again are met. Otherwise, they will lose customer goodwill. Okay, they deal with problems and logistics. Okay, facilities, supplies. Where do they get their supplies? For example, if they are raising chickens, the San Miguel Pure Foods would want to know where would they get the chicken feed, or would they formulate their own chicken feed. Okay. So really, when we do try to solve problems, we grapple with questions. Right? We break the problems into smaller sub-problems. Okay? Ordering problems, so inventory type of problems here. Okay? So what I'd like us to realize is the importance of asking questions. Okay? When we are faced with a problem, and when we analyze the problem, step number 2, when we devise a plan to solve the problem. Okay, so these are the actual words of clients who come for help and the solution of their business problems. So these are not textbook problems anymore. These are real-world problems. So the resources, inventory means what is left after meeting the demand. So if you have extra oversupply, then you will have to put it in a warehouse and you have holding costs. Familiar with this? How many of you have at least I have visited this place at least once? Or do we have one like this in Los Baños? Yes, okay. Nagugutom ba kayo? Nag-breakfast kayo? Okay. Notice that there is a dash there, KFC Mr. Donut, okay, because they are run by the same ORT. Okay. And one of my students is staff or was employed by KFC. She took a course in linear programming, and she developed this model on cutting the chicken. So she just used a linear programming model to automate the decision-making process. So there is a pattern in the cuts. Okay? How frequent should the pattern be used? So next time you feast on a chicken, not necessarily KFC, then you start wondering, how did they cut this chicken? Okay. Chicken sourcing, where would they get this chicken? Or would they get it from San Miguel Pure Foods or other sources? Would they grow their own? So these are the things that they need to answer. And what type of chicken should they use at minimum cost? Of course, you have a goal of minimizing the cost. Okay, and then of course, the donuts. Okay, how many of you like donuts? So, and you want fresh donuts, right? So, how would you solve the problem of always coming up with fresh donuts? So you must make sure that the delivery is not stuck in traffic, okay? Or it should take the shortest path, because that would also mean minimizing your transportation cost in the delivery. Okay? Minimize transportation cost, then you meet the donut freshness requirements, and you want to avoid late delivery. So these are the criteria. And then you want to increase the donut freshness per shop. Okay? So we also have problems like assigning agents or salesperson. So this is now, if you want to know more about this, I'd like you to check out. We will upload the sites here in our Facebook group, but just to introduce, we have a very good reading material for Better or for Best, my operations research story. He is the current president of the Operations Research Society of the Philippines. He has gone from many different companies, and now he's with, I think, Nielsen Group. Okay. So they deal with assignment models in the real world. So this one is is a miniature version of the assignment model. We only have 4 sales zones, we only have 4 sales managers. But imagine in the real world, we have hundreds of zones, and we have hundreds of, or even thousands of managers for big companies. So we have data, okay? Notice, discrete yung data natin, di ba? So we can make use of 0-1 programming here. If you assign manager A to the north, then that gets the value 1. If not, then it gets a value 0. Remember our binary arithmetic? So it's a 0-1 programming problem. Okay? So finance. Okay, problems and finance. Remember this one? Do you recognize this? What do you recognize from this one? The French connection. Okay, from Newsweek. And remember this? How many minutes did you spend reading this? Look at the number of pages. The cover, picture, and then just 2 pages. But many of you said you had difficulty understanding the article. But at the last reading, I hope you got the message. Okay. So, is there a problem on finance here? Do you realize how big the problem is? So that's why, so you will not be duped, or you will not be lured in investing at something that you are not familiar with. You should know your math, or consult those involved in financial derivatives. Okay. So these are financial problems, just run through. I hope this will whet your appetite to look for more. Because investments, they entail risks. Okay, so the higher the interest rate, the higher the risk. Okay. So you have heard of news about investors who are crying because their money went to nothing. Remember those news? So then make sure that before you, one thing about investment, don't put your eggs in one basket. Okay. We have a very good program for portfolio management. It's quadratic programming. Okay. It involves functions of degree 2. Okay. Now, a while ago, we looked at the games that wizards play. And this time, because it's election time, maybe it's worth studying how people play games. Do you see game playing in our advertisements now, pre-campaign advertisements? Okay. But let's just simplify how game theory is applied in politics. Okay. This one is very, very simplified, just to illustrate. So we have the options, and then we have what we call payoff values arranged in matrix form. And then the payoff values are assigned by the decision maker himself. So it has something to do with the valuation of the decision maker and his advisors. Okay, so we have this. So you can make arrangement for these values in a 2x2 matrix. So let's say if the options will be visit or not visit. Okay, so it will come out like this. And then you have the possibility of winning and not winning. Okay, so it's like the politician is here and these are the voters. Okay, so it's a game that is, although we don't see the politician as the opponent of the voter, but when we list down the options, we have this structure. And then you place the values here. So when you visit and you win the region support, you get 7. Like that. So you enter the values and then you apply game theory criteria. And that's the maximum criteria or the minimax criteria. So we'll have more of this in the next lessons after we've gone through the overview of world problems. So the question there is, if you were the candidate, would you visit the region? So if you don't visit the region and still win, that's a good thing. Kaya nga it has a 9 as a value. Kasi wala kang kahirap-hirap and you still won. So that's the way the payoff value 7, 9, -6, and -5 is. Now, why is the visit and then lose a -6? That's more negative than a minus. Visit and lose. Because you spent for the visit and yet you lost. But when you do not visit and lose the region support, that's less negative. At least you didn't spend anything, right? So that's the importance of knowing your positive, negative values. Okay. So from this example, so far we have learned that problems are more manageable with math and the inspiration from the natural optimizers. Okay. So by now, I hope you have seen how math helps us know way more about something that we ever should. So I would encourage you to be more mathematical in the way you see the world around us and the way we handle problems. So let's revisit our objectives. Have we achieved or attained the objectives? Okay, first, can we name some natural optimizers? Okay, that's a very low order thinking skill, but can you discuss, can we go beyond this? Can you discuss how the bees would optimize? Okay, next. Can you cite, at least cite lang naman, some real world problems that can be solved by discrete math? Okay, now, because of our limited time in this class, what I'd like you to do is to keep on naming some natural optimizers, aside from the ones that we discussed. And then you can keep citing real-world problems that can be solved by discrete math. For those in Econ, and if you have taken a quantitative course, I'm sure you already know some of those problems. For those in applied math, those of you who have taken Math 19, okay, I'm sure you can cite. For those who are not taking math, I'm sure you can learn it, even if you are not a formal math major. Okay? You can still learn it, at least read up on the things that would interest you. For example, I would recommend this, okay, for your enrichment. We had a TED, are you watching TED? Can you tell me what TED means? Technology. What's the E? Entertainment. And what does the D? Everyone is watching TED, you don't know what it means? Okay, can you Google now, right now, if you have connectivity? What does the D stand for? Okay, clue, beautiful. What's that again? Beautiful. That's what the artists do. They come up with design. Okay. The TEDx is a program that, have you seen TEDx UP Diliman? You should watch TEDx Diliman when Joey Ayala refashioned the way we sing the national anthem. Okay. TEDx ADMO is Ateneo de Manila University. Okay, so you can easily download this. But if you do not have access to the internet and you don't have the luxury of watching the YouTube show, you can always go to the paper. And maybe you can use this in your special topics or in anything. The title is Game Theory, People Power, and Philippine Politics. So what Queen Ali did was, in the TEDx talk, what she did was to share an experience with her experience with a student who was making a decision. And then she had to parallel it with the way we conducted the EDSA revolution. Okay, that's interesting, right? So it's like there is a matrix like this for the evaluation of the People Power Revolution or the EDSA revolution of 1986. So that's very interesting. I strongly suggest that you visit the site. Okay, so now time for tweet. Okay, so what do we involve in the tweak? One, you can reinforce the learning by talking about what you learned in so few characters. And or, let's say if you can now find an object with a hexagonal structure, then you can point it out. Okay? Or you just saw something na, kaya pala ganon kasi hexagonal yung kanyang structure. Or you can react to the natural optimizers or any of the problems that we showed you in the real world. Or you can make a resolution like, from this time on, maybe I should be more attentive to my surroundings to see how the natural world can inspire, let's say, a product. For example, the design of a car that's more efficient in its running was patterned after a fish. Or you can connect it to your course, your field of interest. So there are many possibilities for your tweak. So while you're doing that, may we have the honeybee and the honeycomb, because we will let our expert packaging person to have a taste. Is it sweet? So we want the honeycomb back so that other students can have a look at it. Or you can say, I'd like to visit the UPLB apiary. Where is the apiary? Biocide. Okay. So you can look at how the bees, did you happen to look at how the bee, in process when they are making the hexagon? That would be interesting if you can look at how the bees do the hexagon. Or if you want to see them dancing.